Good morning, my dear students. Now, this is lecture number 1 in our solid-state electronics course. If you remember 1 week ago where we start our course with lecture number 0 and we deal with the general course outlines, we settle some protocols related to the online teaching, and even we make a very smooth start when we start talking about the material from a crystalline lattice point of view. We study some general and some famous lattice structure, including the face-centered cube, the body-centered cube, and the simple cube, and even we go to the diamond structure, which is related to the silicon atom, one of our most famous material in the electronics industry. Now, and for the next 3 lectures, we are going to dedicate ourselves to what we can call the needed introduction in electrical material that should make us capable of dealing with different electronic devices, mainly the transistors, as we mentioned in lecture number 2. So now, please allow me to share my presentation to start our first lecture. Okay, so I hope that now you can see my presentation, and also let's turn to the front camera so we can start dealing with this lecture. Okay, as you can see from this slide, the title of this lecture is Semiconductor Fundamentals. So we are going to tackle actually a general introduction about different types of material, and then we will go to narrow down to what's called the semiconductor material. The main objective, let me say, for this lecture is to study what is the difference between conductor, insulators, and semiconductors, and also to try to investigate why we are going to choose semiconductor material for electronic industry. So in order to start this lecture, let me start with a very, sorry, let me return back some slides. Okay, so let me return here. So in order to start the lecture, let me first start with investigating a very simple example. So let me return back to the class. What if you are now in an electronic lab and I told you this is a material, this bar, this cylindrical bar is a material, and I need to investigate in lab what is or to what extent this material is a conductive material concerning electricity, of course. So we are in your electronics or circuit lab. Maybe some of you already attended labs in the 011 lab in our building 8 circuits lab. So you know, or maybe you are familiar with the lab, some of you, of course. So now this is an unknown material, and I know you need to know what is this material, or to what extent this material is a conductor. So let's now try to think together how we can make such an adjustment, or how we can make such a structure. So let me try to adjust our camera quality. Okay, that's perfect. Okay, so we now have a cylindrical bar of a certain type of a material. As you can see here, this is an unknown material. From your high school, maybe from your prep year, you know what's called the Ohm's law. Ohm's law states that voltage and current are directly proportional, and the constant for this proportionality is what's called the resistance R. So voltage and current are proportional. Great. How can I use this simple Ohm's law in order to investigate to what extent this unknown bar is conducting electricity? So let's enter the lab and pick up a voltage source and connect this voltage source, I believe you already know the structure or the shape of the voltage source. So let's now connect this voltage source with a positive terminal and negative terminal. Let's connect it to the material. But in order to measure the current, we also need to connect what's called an ammeter, or a device that can measure the current. And also, we can connect in parallel a voltmeter to measure the voltage. So, by doing this very simple experiment, you can measure the current and the voltage of this bar. And now you can calculate the resistance. You know the V and the I, direct substitution in the equation, and you can calculate R. Okay. And again, from your high school and or maybe in prep, you know that this R is equals to rho times L over A. So what is rho? Rho is the material resistivity. L is the length of the material, which we can here indicated by this length. So we call this length L, and A is the cross-sectional area of this material. So very simple. Using this equation, you can calculate, or now from the first equation, from Ohm's law, you can calculate R in terms of the V and I. You know the V and I, so you can calculate R. Now we know the bar, we have the dimension of the bar, so it's very easy. You can substitute. Now you have, you know R, you know L and A, because L and A are the dimensions of the material, and then you can calculate what is called rho, which is the resistivity of the material. Now, finally, we know the term sigma equals to 1 over rho. So sigma is what we can call conductivity. So sigma, or the conductivity of the material, is simply that 1 over the resistivity. It's inversely proportional. So as the resistivity increases, the conductivity decreases, and vice versa. So by these simple 3 steps, and only using a voltage source, the voltmeter and an ammeter, you can calculate the resistivity of different materials just by doing this very simple experiment. So if we go together into the lab, and if we do such an experiment together, let me now return to my slide. Let me again change the camera. Okay, so here is the relations I just mentioned, the same relation. Here the bar with the length L and the cross-sectional A, and here we have the old equation, and we can calculate the sigma, or the conductivity of the material. So if we have, for example, something like 20, 30 bar of different material, we can repeat the same experiment over this number of samples, and with each measurement, we will have a new sigma, or a new conductivity, indicating the conductivity of the material. Now, if we did such an experiment, we will find something like that. We will find that we have some materials, something like the silver, copper, iron, aluminium, some other material, with a relatively high conductivity in terms of something times 10 power 7 or 10 power 6 or maybe 10 power 8. So this is a category. And we also have another category, for example, those ceramic materials or polymers, where the conductivity is extremely low. Here we are talking about something 10 power negative 10, 10 power negative 9, 10 power negative 14, negative 15, negative 17, to a very low conductivity. And we will have the third family or the third category, where the number is actually in between. It's not that high like the first family in red, or it's not that low like the family on the right hand side. It's something in between. So something 10 power negative 4, 10 power negative 3, 10 power 0, in between. Accordingly, we are as an electrical engineer start to give names to these three families. We will call those materials where the conductivity is very high, we call them as the conducting materials or conductors. On the other hand, we will call the other right hand side family where the conductivity is very low, we will call them the insulators or the non-conducting materials or the dielectrical materials. All the three terms will have the same meaning. And then we will have an in-between family, which have a conductivity not that much, but not that low. So we will call them a semiconductor material. They are to some extent conductor, but they are not as good as that metal. Now, this experiment is what we can call in science experiment based on observation. We make a test in the lab, we pick up some numbers, and we start to analyze the numbers, and then we start to classify materials based on these numbers. But we don't have the ability to answer the question why. Why copper is a conductor? Why glass is an insulator? Or why silicon is semiconductor? We have some observations, but we don't have interpretations. We don't have analysis. We don't have justification. What we are going to do during this lecture is we are going to start to solve or to answer this question, this why question, from a chemical or a chemistry point of view, from a physical point of view, and from an electrical perspective or point of view. Let's start with our friends with a chemistry background. When we go to a chemical engineer and ask him why copper is a metal, why copper conducts electricity, and why glass doesn't have the ability to conduct, and why we call silicon a semiconductor. Okay, in order to answer the question, either from the chemical, physical, or electrical perspective, we have first to define a very important thing. What is electricity? So here we are classifying these materials based on their capability to conduct electricity. So in order to investigate, we have to define what is principally electricity. So again, I'm sorry, in this lecture, I will have to go to my whiteboard more than one time. So I'm sorry in advance for that. Let's now turn again to the whiteboard. Okay. Okay, that's perfect. By the way, all these written slides will be scanned and will be uploaded to you on or over the e-learning. So you don't need to write or to copy paste what I'm doing. All these slides will be directly delivered to you through the e. So, what is electricity? This is a very important question. So please don't forget this important definition, because actually during the whole course, maybe during your 4 years of study, maybe during your life, you will use the same definition in order to define electricity or electrical current. So if you return back to your physics in the high school or maybe in prep, you know this important definition, that I, where I is the electrical current, equals to dq by dt. I believe that all of you have already seen this definition before. I equals dq by dt. So in order to study this definition, we have to know what is q And what is t? Of course, t here is very simple. T is time. So this is a direct differentiation with respect to time. But what we can say that the term d by dt represents rate of change with respect to time. So this is the rate of a change with respect to time. So this is the t. But what is q? I believe that most of you know already q from your physics classes, that q is simply charge, or to be more accurate, it's the electrical charge. But what is the electrical charge? From our basic understanding to the electricity, we know that electrons are electrical charge. I believe that you know that the term E, or sometimes we call it Q, which is equals to 1.6 times 10 power negative 19 coulomb, represents the charge of a single electron. So this is an example for charge. So electrons are charged. But the question is any type of a charge or any type of electron can create electrical energy or can create current? The answer is simply in this equation. In order to have electrical charge, you have to have charge which is somehow have a variation with time, or we can call it you should have a moving charge. In order to have an electrical current, you should have a moving charge. So maybe I believe that by this word you are not still 100% understand the concept. It's still not so clear for you. But consider these 2 points, and I believe that by the end of this lecture you will surely, inshallah, understand these 2 points. In order to have electrical current, you have to fulfill 2 important conditions. The first condition is that you have what we can call a free charge. What I mean by free charge is a charge that has the capability, that has the ability to move, not a bounded, not a fixed charge. So first requirement to have an electrical current is to have a free charge. The second requirement is that this free charge can move, which is d by dt. Because simply, if you have a static charge, it will not create current.